happens when an AI team gets access to two NVIDIA L40S GPUs. That's 96 GB of VRAM, 36,000 plus CUDA cores, built for multimodal and multi-team AI development. Now that's not just an upgrade, it's the foundation for faster experiments, smarter products, and shared progress. Welcome to KeyValue's AI Lab, where we build, fine-tune, and accelerate the next generation of intelligent systems.
At KeyValue, we always make sure that AI is a mindset rather than it just being a capability. From research to product, we actually build things with AI at its core. Our AI lab is where we actually explore new techniques, push model boundaries. It is where actually we bring the innovative ideas into production. To keep up with the fast-paced tech curve, we recently made a major upgrade to our AI lab. Two NVIDIA L40S GPUs to power our compute setup. Each one is packed with 48 GB of ultra-fast GDDR6 VRAM, which is capable of handling massive models even at heavy workloads. Also, with over 18,000 CUDA cores each, these GPUs are actually built for parallel processing at serious scale. And thanks to the ADA Loveless architecture, we are hitting up to 91.6 teraflops of floating point 32 compute power, which is some serious horsepower when it comes to deep learning workloads. All of this is actually running at a 350 watts of power, which means that high performance and high efficiency without any compromise. We primarily use this setup to train and fine-tune state-of-the-art large language and vision models. The combined VRAM of 96 GB and the large number of CUDA cores that we have available on our setup help us to load and deploy models like NanoNet's OCR, Google Gemma 3 27 billion, or Qwen 2.5 7 billion models. This setup also helps us to deploy virtual LLMs also efficiently. Having dedicated access to the GPUs like the L40S has made a significant difference in the way we work. Earlier, actually, we used to have tools like Colab Pro or Jarvis Lab. It worked, but there were actually some limitations there. But with the consistent access available to our latest GPUs, we could actually easily load the models, deploy them, run the latency checks, and benchmark. All can be done without any delays or limitations. It's a great setup too, like 8 terabytes of NVMe storage and 400 Mbps of network bandwidth, which means that everything from downloading models to training large data sets and calling APIs, everything is done in minimum latency, and there is no chance of any sort of input-output bottlenecks as well. So everything is done real smooth and quick. Together, it gives us an environment which is fast, reliable, and scalable, which helps us actually experiment more and iterate faster, avoiding the usual bottlenecks. For example, in one project, we actually used a domain adaptive pre-training to improve an existing LLM which was trained on a large dataset. And in another one, we actually aligned a 7 billion decoder model using direct preference optimization. All of this was done on this machine. We are still training, fine-tuning, and aligning models which is used for different use cases without worrying about any cloud cost. In-house GPU access has significantly improved our product development and evaluation process. We are planning to implement virtualization on top of these GPUs so that multiple teams across the floor can use this as a shared resource to meet their needs.
We're always learning, always adapting. This helps us do that a little faster. And this upgrade is more than just better hardware. It's a step forward into how we learn, build, and push what's possible with AI. Because here at KeyValue, we don't just follow the curve, we lead it.